Hi, I'm Pat Kelly. Okay, in this problem, they give us vectors u and v. The directions say to find the area of the parallelogram that has these two vectors u and v as adjacent sides. Okay, this actually isn't too involved because, too involved to figure out how to do it, because it's a really good application of the cross product. If these two guys are adjacent sides of a parallelogram in three-dimensional space, then the magnitude of the cross product is our answer. So exciting. All we have to do is jump right in here and do our usual cross product work. Okay. Which what I would typically do is set up this determinant form where I have I, j, k in the top row, and then these components 4 minus 6 in the second row, and then these guys 0, 4, 6 in the third row. And then we go into our cofactor expansion work to find the cross product. So I'm going to have 4 minus 6, 4 positive 6 as my submatrix. I need to find the determinant of, and then multiply by that I vector, minus. Next submatrix is going to be 4 minus 6, 0, 6. I'll need the determinant of that, multiply by the j vector. Let's write down the wrong vector there. How's that? J vector, plus determinant of my next submatrix, 4, 4, 0, 4. And that'll multiply by my k vector. Okay, now let's do our little crisscrosses and get some results here. 24 minus 6 times 4, negative those, so plus 24. Multiply by that I vector. Subtract. Crisscross here looks like 24 minus 0 times the j vector plus 16 minus 0, right, for my crisscross is the k vector. And let's just clean it up with a little bit of arithmetic and get 48 I. Is this going to be minus? Yeah, minus 24 j, and then plus 16 k. Okay, cool. You got your result for the cross product. As I mentioned, all we need now is the magnitude of that. You've got your answer. Okay, so my area here equals, I'm just looking for the magnitude of our u cross v, which equals square root of each of these components squared, minus 24 squared plus 16 squared, all under the radical hat. Okay, some big numbers. So I can do this in my head. Some squaring and some square root, and that should end up equaling 56, right? I'm just kidding. I did it ahead of time on a calculator, but you should get 56. Plug this in, you'll get the same result. Okay, 56. It's an area, so I'll even say square units for my final answer. Okay, that's it. Try some on your own.